Okay, good day. Now we're going to continue about hexadecimal numbers. Okay, we go to the next slide. Okay, hexadecimal numbers. The fraction numbers, the weight are negative power of 16, similar as in the previous numbers, that decreases from left to right, beginning with 16 to the power of negative 1 minus 1, okay, which is equivalent to 0.0625. Compact way to express binary numbers and codes, we use 4 bits binary boundary. Okay, for example, this is the decimal number 0. The equivalent in binary numbers is 0, 0, 0, and the equivalent in hexadecimal number is 0. Okay, and for the now we see from the 9 of base 10, the binary number is 1001, and the hexadecimal is also 9 to the base of base 16. For the 10 of base 10, so you have the binary equivalent is 1010, and the hexadecimal is where it started to be different, which is A. Okay, so A 11 we represent by B, 12 we represent by C, 13 represent by D, 14 represent by E, and 15 represent by F. Okay, hexadecimal numbers. Now we're going to see the hexadecimal conversion to decimal number conversion. Okay, the decimal equivalent can be accomplished by multiplying each hexadecimal. Okay, we multiply each hexadecimal digit by its weight and summing the products. For example, we convert the hexadecimal number B to F at base 16 to decimal. So you can see there is we multiply by its weight. Okay, for example, this one times by this one times by this one times by this one, and this one times by this one. Okay, so B times 16 to the power of 3, then actually you have to know that B is actually 1, right? Okay, so it's good to, if you can memorize a bit, 2 times 16 to the power of 2. F, F is actually 15, right? So times by 16 to the power of 1, and 8 times to the power of 16 power of 0. So you have this, you sum it, then you have this 45816 base of 10. Next, we go to the conversion for the decimal number to the hexadecimal numbers. Okay, for the whole numbers. So how we actually do it? We do it by repeated division. We divide the decimal number by 16, and we divide the result, each resulting quotient by 16 until the 0 whole number quotient, means, let's say, for example, 0 point something is obtained. Take the remainders generated from the division and form the hexadecimal numbers, and the first remainder is seen as least significant digit, the first remainder that you have, and the last one will be the most significant digit. Example, convert the decimal number 650 to hexadecimal. Okay, 650 you divide by 16, you have 40.625. So this one you times by 16, you get 10. 10 is actually A, and then you take this one, you further divide by 16, you get 2.5. Then the 0.5 is times by 16, you get 8. To proceed with 8 as the remainder, hexadecimal remainder. Then the 2 divide by 16, then you get 0.125. Notice this is the first 0 whole number quotient, okay, that you have. So you stop here, and this one you carry on multiply by 16, then you have 2, then the hexadecimal remainder is 2. So arranging it, then you have this as the most significant digit and this as the least significant digit. So 288A. Remember to write the best number. The next is we want to convert the decimal numbers to hexadecimal numbers for the fractional numbers. Okay, how we do it? We repeated multiply by 16. Okay, multiply the decimal number by 16. Repeat multiply each resulting fractional part by 16 until the fractional product is 0, until you have 0.00, for example, nothing left behind anymore as a fractional number. Take the carries generated by the multiplication to form the hexadecimal numbers. The first carry product, okay, the first will be set as the most significant digit, the first, and the last carry will be your least significant digit. Now we go to the example. Convert the fractional decimal number 0.3125 to hexadecimal. Okay, you have this. You time by 16, then you have 5, right? And you notice there is nothing any more digit as the fractional number, only zeros, then you stop it there. So now 5. You carry the 5, then the 5. Then this is your most significant digit, okay? So you see the fractional parts are all zeros, okay? You see you have your 5 here. So 0.5, okay? Base 16, okay? For the fractional numbers. So 0.3125 base of 10 is actually 0.5 of base 16. Now the next one, we go to the binary to hexadecimal conversion. Okay, we want to convert the number in binary to the number in the hexadecimal. To convert binary to hexadecimal, simply break the binary number into 4 bits group, 4-bit binary, starting from the least significant digit. Then replace each 4-bit group with equivalent hexadecimal numbers. Example, convert the binary numbers 1, 0, blah, blah, blah to hexadecimal. First, you break it into 4-bit group. Okay, like this. Then this one, you know, it is 7. This is 5. This is 10. Okay. This one, 10, 11, 12, right? Because this one is 2 to the power of 3, which is 8. This one is 2 to the power of 2, right? So it's 4. Okay. So it's 12. Okay. In a binary, in a hexadecimal, in the decimal numbers. So 12 is actually C, right? So you get this CA5716. Next example, convert the binary numbers, this one, to hexadecimal numbers. Okay, you break again into 4 bits group 1, 2, 3, 4. You see it's not enough of 0, so you add another 2. Okay, so you have 0011 is the 3. This one is F15. This one is 1, just 1. This one is 6, 6, and this one is 9, 9. So convert the binary numbers. This whole long number is equals to 3F169 to the base of 16. Now we go to the next one, is the hexadecimal number to binary numbers. Okay, You convert the hexadecimal to binary number. Simply replace hexadecimal digit with the appropriate 4 bits group, 4 bits boundary. Okay. For better understanding, we go direct to the example. Convert the hexadecimal number 10A416 to binary. So you just divide this according by digits, and then you simply replace with a 4 bits group. Like for example, 4. What is the equivalent number in binary in 4 bits group? The same goes for A. The same go for zeros. The same go for 1. Like for A is actually in decimal number is 10, right? So what is this number in a binary number? So you arrange accordingly, then you get 1010. Okay, because this is 2 to the power of 8, 2 to the power of 3, where you get 8, and this is 2 to the power of 1, where you get 2. So 8 plus 2 equals to 10. 10 is A. So in a binary is also the same here. So it's 10. So convert the hexadecimal number CF8E16 to binary. The same. You divide by like this. Then you replace with 4 bits group of the binary numbers. Okay. Now, this is the exercise. You can try it out on your own. And let me know if you have any problem with it. Okay. Thank you.